So what is gravity? Gravity is what's keeping us here on the surface of our planet. It's what brings the moon around every night and orbits our planet around the sun. At its essence, gravity is an attraction towards a body of mass that is created by that body of mass. That means that everything that has mass creates a gravitational field, and objects in that gravitational field will accelerate and be attracted towards the mass creating it. So, let's say we have a mass. That mass is going to create a gravitational field around it. Now let's say we have an object inside that gravitational field. That object is going to be attracted to and accelerate towards the mass. And let's say we have a second object that's a little further out, but still in the gravitational field. Well, it's also going to be attracted to that mass. However, because the first object is closer, its acceleration is going to be greater than the object that's farther away. In order to understand why the two objects have different accelerations, all we have to do is find the formulae for the acceleration of gravity caused by this mass. To do this, we need three things: the mass of the object creating the gravitational field, the distance from that object's center of mass, and the gravitational constant g. Once we have them, we plug them into our formula. The acceleration of the gravitational field is the mass of the object creating the gravitational field divided by the distance from that center of mass squared times big G. Now last, we can see that the two objects were at different distances, and therefore they had different accelerations, with the closer object accelerating faster. However, if the two objects were the same distance from that mass, then they would both have the same acceleration.
Let's use a real-world example to see how this works. So right now, we're on the surface of the Earth, and the Earth has a large mass that creates a gravitational field, which is centered at the center of the Earth, where its center of mass is. Now this big bowling ball and this tiny apple are both on the surface of the Earth with me, and so they're the same distance away from the center of the Earth's mass. That means that regardless of how heavy one is over the other, they will both accelerate at the same exact rate towards the center of the Earth. Pretty neat, huh? Now that we've seen the acceleration of the Earth's gravity in action, let's calculate what it is. The first thing we need is to know that the mass of the Earth is 5.972 times 10 to the 24th kilograms. We also know that the bowling ball and the apple are on the surface of the Earth, and the distance from the center of mass from the Earth to the surface is actually the radius of the Earth, which is 6378.1 kilometers. Plug in this into our equation for the acceleration of gravity, that the mass of the Earth divided by the radius of the Earth squared times big G gives us 9.8 meters per second. So anything located on the surface of the Earth will accelerate towards the Earth at that amount.